A new comet has quietly entered the cosmic stage, designated C-2025 V1 Borisov. It was discovered only days ago by Gennady Borisov, the same astronomer who identified 2I Borisov, the second confirmed interstellar object ever observed. So far, the object is classified as a long-period comet, not an interstellar visitor. Early orbital data from the Minor Planet Center show an eccentricity just under 1, meaning it's gravitationally bound to the Sun and likely originates from the Oort cloud. If it were interstellar, that number would have been clearly above 1. For now, the evidence suggests it is native to our solar system, though its path will become clearer as more observations come in. At the moment, Borisov lies almost exactly between Earth and 3I Atlas, around 70 million kilometers away, brightening each night, though only slightly. It's currently hovering near magnitude 13, barely within reach of medium-sized telescopes. Its orbit dips below the ecliptic plane before swinging upward again, heading toward a perihelion on November 16th, at just under half an astronomical unit. Most images show only a compact coma with no obvious tail, a trait surprisingly similar to 3I Atlas, another object that has puzzled astronomers for displaying strong activity near the Sun but almost no visible dust tail. After passing the Sun in late October, 3I Atlas endured some really intense radiation and solar storms. Normally, this is when a comet erupts dramatically. Instead, new post-perihelion images show the object remaining intact, actually brighter than expected, yet still without a visible tail. While, the internet has exploded with speculation, scientists suggest several natural explanations. A dust-poor composition, gas-dominated activity like carbon dioxide that's invisible in optical wavelengths, or maybe even a viewing angle that hides the tail from Earth. Upcoming observations from ESA's JUICE spacecraft may soon reveal what's happening around this unusual traveler. Meanwhile, ground-based data hint that something strange occurred a few days before its closest approach on October 29, 2025. Researchers noticed that 3I Atlas brightened far more rapidly than a typical comet, possibly even shifting in color. At the same time, the far side of the Sun was erupting with massive solar flares and coronal mass ejections. 3I Atlas passed directly through this turbulent environment. The flares didn't alter its course, but they gave scientists plenty of new data to analyze. The real surprise wasn't the solar activity, it was the trajectory. After perihelion, when the folks over at JPL recalculated the orbit, the numbers just didn't align perfectly with what you'd expect from standard gravitational motion. So, to fit the data, NASA navigation engineer David Farnokia added two non-gravitational parameters, A1 and A2. These describe tiny continuous accelerations acting on an object, usually caused by outgassing, and extremely rarely by something else. Now, for 3I Atlas, both of these parameters turned out to be non-zero. According to Farnokia's model, the comet experienced a small push of a few hundred kilometers per day squared away from the Sun, and a weaker sideways push along its trajectory. Interesting, right? Cosmically speaking, these forces are really tiny, detectable only through precision orbit modeling, yet their presence means something is nudging the object. It's fascinating how even the smallest forces can have such an impact in space. But before we dig deeper, a quick word from today's sponsor, Squarespace. Their AI-powered design tools make creating a website effortless. Fluid Engine, their drag-and-drop design system, lets you customize every detail. Built-in analytics show who's visiting your page and how they found you. Try Squarespace free at squarespace.com, and when you're ready to launch, go to squarespace.com/territory to save 10% on your first purchase of a website or domain. Now back to the mystery. What caused the non-gravitational acceleration in 3I/Atlas? The simplest explanation is outgassing, sunlight heating the surface and releasing jets of vapor that gently push the comet. This is actually pretty common among active comets. So, why is everyone focused on 3I Atlas? Well, it's because of how dramatically it brightened, how quickly it happened, and honestly, how unusual its color change was. Shortly after JPL's update, Harvard astrophysicist Avi Loeb published an analysis examining the physical implications. If the acceleration came from natural outgassing, then by momentum conservation the object must be losing mass, and we can estimate how much. Assuming a typical gas jet speed of a few hundred meters per second, Loeb calculates that 3I Atlas would need to lose material rapidly enough to give it a 6-month half-life. That would produce a massive plume of gas and dust, easily visible throughout November and December. ESA's JUICE spacecraft could spot it in early November, and later, when the comet makes its closest approach to Earth on December 19th, telescopes worldwide, including Hubble and JWST, will get their chance to confirm or disprove this. If a large plume is detected, the natural outgassing explanation holds. If not, something else is responsible. Another team studied images from Stereo A and GO-19 taken in September and October. Their analysis showed the comet brightening 7 times faster with decreasing solar distance than a normal comet. Around the same time, observers noticed something even more bizarre. 3I Atlas appeared bluer than the Sun in certain coronagraph images. That's extremely unusual. Most comets look yellowish or reddish because dust scatters sunlight. A consistent blue tint usually indicates glowing gas emissions. Loeb offers 2 possibilities. First, a natural explanation, emissions from ionized carbon monoxide, which glows blue under ultraviolet radiation, and second, a more speculative idea, an internal heat source or some unusual physical mechanism. He isn't arguing for exotic explanations, only that the data shouldn't be dismissed. Now, let's stay grounded in what we actually know. The JPL data does show measurable non-gravitational acceleration. The deviation is real, not a numerical artifact, but the total effect is tiny. Even if the acceleration continued for a whole month, 3I/Atlas would drift only tens of thousands of kilometers, far from enough to alter its trajectory significantly. It's not heading toward Earth, not making course changes, not posing any danger. In short, 3I/Atlas is behaving like a comet, just a very unusual one. As 3I/Atlas drifts outward toward Jupiter's orbit and Borisov sweeps inward toward its first solar encounter, both objects provide a rare opportunity to study the boundary between ordinary comets and possible interstellar visitors. What do you think? Share your thoughts in the comments, and don't forget to subscribe to Next Now. This is your space.